This week in CIST 2611, we'll look at Chapter 8, Operating System Hardening. In this chapter, we're going to look at the fact that you need to secure your operating system. So you may make sure your operating system is, and the software is up to date, that it has the correct settings. And this chapter is going to cover Windows client versions for 7 and later, which is 7, 8, 8.1, and 10. Some of the tasks that we're going to look at is disabling unnecessary services, configuring the registry, enable the firewall, and also configuring your browser. When you're going to secure your operating system, when you're going to harden your operating system, one of the first things you need to do is disable default user accounts and groups. It's also better to disable the default administrator account rather than just renaming it. If you're not going to use that, make sure you disable it. There are other accounts that need to be disabled also if not used. Example is the IUSR underscore machine name. So when you're running an ISS, it's going to have a default username is going to be created for it. And that's going to be the name is the IUSR underscore and the name of your machine. This is one of the common accounts that the hackers will try to get into, trying to compromise it. ASP.NET. So if you're running ASP.NET, you have a default account that's going to be created for web applications. If the hacker is familiar with the .NET, they could target that account. And also database accounts. You have different types of relational databases, management systems like SQL Server, and those create a default user account. So that's something that is a target for anybody who's trying to get the data. Also, as we brought up a couple times, I want to make sure that you assign each account you do create with the least privileges needed to perform the job. So we stay with the principle of least privilege. Some other settings you need to look at is setting your Windows security policies, maybe a password policy where you have the history, the age, the length, the complexity of the passwords set. Allow account lockout policies, because these are the policies are going to determine how long, how many times a user can try to log in, and how long to lock them out for each unsuccessful attempt. You can see tables 8.1 through 8.4 for recommended policies in your textbooks. Now, when you're writing a policy, a couple other things you need to consider and should be in there is that the user should not write passwords down. Users should not share passwords. And once again, the user should have the least privileges required. You only want to give someone enough permissions to do the job they're required to do and nothing more. All right, so we're going to look at some different types of registry basics. In here, first we got the you will edit your registry using the regedit. When we looked at older versions of Windows, like Windows 95, 98, the registry systems, the registry directory is going to be hidden in a file called user.dat or system.dat. Since Windows came out with Windows XP, those files have been moved to a system root, system32 config. And now, since Windows 8, those files are now been moved to ntuser.dat. Once again, you can't open those files and go in and edit those. You need to use the regedit tool to edit your registry. Now we do have a couple of top level selections here. We'll talk about the H key classes root. That's going to contain all of your file associated types, shortcut data, OLE information. The current user, that's got the shows you who is the appropriate user for currently using the machine, who is logged in the machine. Local machine is going to have the information about the hardware, software, and other preferences that have been set on that given PC. The H key underscore users, that's got the individual preferences for each user of the computer. And the current config, that's going to have that's going to link to the local machine, and it's appropriate for the current hardware configuration. Be careful with editing your registry. With this, you can go in and make part of your operating system unstable or unusable. As it says on the screen, if you are new to registry editing, do not practice on a production machine that has critical data. It is very easy to mess up your operating system. All right, there's a couple ways you can secure the registry. One is restrict null session access. All right, so a null session is a Windows way of designating anonymous connections. So you want to restrict that. Restrict null sessions access over named pipes. So restricting access on this helps prevent unauthorized access over the network. And you can look at table 8-5. It will show you an example of how to edit the registry and delete the values to restrict this. Anonymous access registry settings allows anonymous users to list domain usernames and enumerate share names. This should be shut off. You do have 3 different settings for this key. 0 will allow anonymous users. 1 restricts anonymous users. 2 allows users with explicit anonymous permissions. The change TCP/IP stack settings. This is how the registry handles incoming packets. By having these settings properly, it does help you reduce the risk of having your vulnerability to being susceptible to DOS attacks. All right, so the next one would be disable default administrative shares. So default administrative shares, these they open default shared folders on each installation for the use of system accounts. They're going to be identical for all Windows machines with the same identical permissions. Skilled hackers can use that as a starting point for getting access to your machine. So you disable these 2 ways. You can use the stop or disable the server service, or you can edit the registry. All right. You also want to disable remote access to the registry. By default, later versions of Windows has already got this cut off. Earlier versions may still have this issue. All right, so when we look at Windows services, these are services that run without direct user intervention. By disabling these unneeded services, you can increase your security. You would use the services.msc console. That's where you will manage your services. Just be careful and make sure you don't disable a service that is needed. The EFS, this encrypts your files and folders. So you can do this to improve your security. It uses a method based on public key encryption. So what happens here is, while this is still going to exist on Windows 7, 8, and 10, now, but in the later version of Windows, the EFS is only going to be available upper end editions of Windows, such as Windows Professional. So there's the files encrypted with a randomly generated file encryption key. It's independent of a user's public-private key pair. And it makes this method of encryption resistant to many forms of cryptanalysis-based attacks. All right, a security template contains hundreds of possible settings that control a single or multiple computers. These can be settings that are set up for including the user rights, permissions, and password policies, and they are going to be something that's easily, it enables the administrators to set these with using the group policy objects. A couple of the security templates, the CIST.dc.inf makes your domain controllers more secure. So it increases the security and communication with the domain controllers. The security CINF is less secure, but it still makes them secure, but not up to the security level of the high security DC security templates. The HISECWS.INF is designed to increase security and communications from client computers and member servers. The SecureWS.INF, that's for client computers and member services as well. And it's intended to do the same thing. It's designed to increase security and communications for client computers and their member servers. The setup security.inf, that template is designed to reapply the default security settings of a freshly installed computer. It can also be used to return a system that has been misconfigured to the default configurations. Many of the security principles that are applied in Linux, as they did in Windows, so you'll make sure that some of the common things, default users and policies are turned off. Services not in use should be shut down. Make sure that you have your browsers configured securely, and also routinely patch your operating system. Some difference between Linux and Windows is that no application should run as the root user. Root passwords must be complex and changed frequently. You also want to disable all console equivalent access for regular users and hide system information in Linux. You can keep your operating system patched and up to date. Windows, you can allow the Windows to update to run automatically. Linux, you can open a terminal window and type sudo apt-get upgrade. One thing I really stress on this is that you do not upgrade your system without testing it first. So if you're in a company and you don't upgrade your system without putting it on a controlled computer before you push it out to the systems that are in production. You will from time to time run into issues to where an update will cause something else not to work. So you make sure you test your updates before you send them out in production. Your browsers also need to be configured correctly. Some privacy settings need to be set, block third-party cookies, prompt for first-party cookies, allows session cookies. You can also set your security settings to limit what can run, such as unsigned components, ActiveX, or Java. So those are some general settings for configuring your browser. Keep in mind that each browser that you use will have different ways of changing settings. But in general, you want to limit cookies. Don't allow ActiveX to run without your knowledge. And also don't allow the scripts execute without your knowledge as well.